Geometric distributions. Waiting time. Get out of jail in Monopoly. To get out of jail, you must roll doubles or pay the bank $50. So rolling doubles means you have 2 dice. And so to roll doubles, there are 6 ways to do that with a pair of die. And there are 36 possible rolls. That means the probability of success, or P, once reduced, is 1/6. And the probability of failure must add up to 1, so it becomes 5/6. In part A, we're going to calculate the probability distribution of getting out of jail in Monopoly in X number of rolls. So we want the entire number of possibilities in chart form. So it's going to be unsuccessful, and its probability. So probability of being unsuccessful. But we're also charting the unsuccessful wait time. So it's not just unsuccess. So there's the possibility that we are successful on the very, very first try. And the probability of success is 1/6. And so that's 0.166 repeat. We may have to wait 1 roll. So the first time we roll, we don't get our doubles. So that probability is 5/6 times 1/6, because the second time out we are successful. And that translates into 0.138. We may have to wait 2 times, in which case our probability of failure now needs to be squared. And then we're successful on the 3rd roll. And this is 115. And this can go on forever. So if I hit 15 rolls unsuccessful, that means our exponent for unsuccess becomes 15. And then there's our successful trial, and this goes on forever. So that is the probability distribution. You can have as many values in there as you like. Just indicate that it goes on again forever. So in part B, we're going to estimate the expected number of rolls before getting out of jail. So part B is going to use the first little bit of this formula. So you can see we're adding up from 0 to infinity. So back to our chart. As we're doing that, we're multiplying. So the wait time of 0 times its probability plus the wait time of 1 multiplied by its probability, and so on down the line. So if you're doing it in this fashion, you might want to add up, 10 of them to be accurate. So if I were to do that and add those all up, I'm going to get a number that's approximately 4.9. The other way of doing this is to use the short form, because when you add all of these up, the formula indicates that it becomes unsuccess over success. So in this case, unsuccess is 5/6. Success is 1/6. When you reduce that fraction, it becomes 5. Which makes sense, because when you use the long form, you're looking at 4.9, which is approaching 5, and there it is once we use the reduced form of the formula. Basketball free throws. Jamal has a success rate of 68% for scoring on free throws in basketball. What is the expected waiting time before he misses the basket on a free throw? So in this case, the probability of failure is 0.68, and the probability of success is 0.32. So instead of waiting to make a basket, we are waiting to miss a basket. So the formula for the expected waiting time becomes the reverse of what you may be thinking. So it's 0.68 over 0.32, which equals 2.1. So we are expecting him to make 2 free throws before he misses. Traffic management. Suppose that an intersection you pass on your way to school has a traffic light that is green for 40 seconds and then amber or red for a total of 60. In part A, what is the probability that the light will be green when you reach the intersection at least once in a week? Well, we're talking about going to school, and the school week is 5 days. So the probability that the light will be green at least once means we're measuring between 0 and 4, because we're going to at least get it one time. The probability of success is 40, and the probability of failure is 60. Those add up to 100, so it's 40 over 100 and 60 over 100. So let's go ahead and do the probabilities. So the probability of not having to wait, so being successful the very first time, is 0.4. The probability of having to wait 1 day is 0.6, 0.4. So there's your 1 day. The probability of having to wait 2 days is 0.6 squared, and then you're successful. And then we have 3 days, and then you're successful. And the last possibility is having to wait 4 days, which means you're going to be successful on the Friday. And when you add all those up, it's 0.92. So that is your probability of at least once in a week. Last bit here, part B. What is the expected number of days before the light is green when you reach the intersection? So the expected number of days is simply Q over P. So that's 60 over 40, which is 1.5. So you're going to expect to wait a day and a half. Thanks for listening.